So Python is a popular programming language that is becoming more prevalent and popular within the data analytics and data science industry. So companies all over the world rely on Python to harvest insight from their data and gain a competitive advantage. So welcome back to the channel and welcome back to Excel Island, where the goal and objective is to learn and master Python over the next 100 days. Today is day 4 and we started this live streaming learning journey a couple of days ago, which is 3 days ago, with introduction to Python, where we've actually covered the Python basics, which is from understanding variables to data types. Then we moved to Python lists. Then yesterday, which was day 3, we did all about functions and packages in Python, which were introduced to basic stats and math function. Then we did a couple of packages in Python. Today on day 4, which is the final chapter of the first course in the whole career track. I think we have 9 courses in this whole Python, which is the data analyst in Python career track on the DataCamp platform. So we're moving to our first package in Python, which is NumPy. So NumPy is a popular Python packages useful for what? Useful for data manipulation, data to manage and manipulate your data and gain actionable insight from your data set. So welcome back to the channel. So my name is Sheriffdeen. I'm a top rated plus freelance data analyst on the Upwork platform. I was looking to upskill myself and on some of my skills in the data analysis space for this year 2024. So I decided to go on a learning journey for a couple of months. So we're on the final. I've started with, when I started this whole learning journey, it all started with SQL, then we moved to Power BI, then we moved to Python. You can catch all the whole previous live stream on the live stream tab on the channel. So welcome to day 4. Without further ado, let's jump back to learning and welcome to this Python learning journey. I hope to see you all the way till the end of the challenge. So do well to download all data sets, the size files, or the files we'll be using, which are CSV files mostly that we can connect to in Python. Under the YouTube description, there's a link under the YouTube description. So make sure to download those files from the link and practice along with me. So let's just jump back to learning and welcome to day 4 of learning. So we'll be completing our introduction to Python on today's live stream, which is the last chapter in that career track. If I go on that career track real quick here, you can see it all started with data analysis in SQL. Then we move to data analysis in Power BI. So if you are looking to upskill yourself in SQL and Power BI, you can catch all the old live stream, the old lessons, or the live stream tab on the channel. Then we are moving to Python. We all started. You can see we're just we are at the beginning of Python. So we still have a long way to go. If I click on data analysis with Python real quick here, you could see the whole career track, which is 36 hours of learning, 9 courses. We are on the first course and we're completing the NumPy part of the course, which is introduction today. So on the next live stream, we're certainly starting with matplotlib, dictionaries and pandas, and so on and so forth. So looking forward to seeing you on that live stream. So let's continue immediately. So this was what we covered from within just 24 hours ago. So we've been showing up consistently over the past 24 hours. So we tried to understand how packages work in Python. Then we imported a package in Python, which was the maths package. We did a couple of calculation and manipulation on it. So we also look at some functions, basic functions in Python, which is maths, and how to write those functions in Python. So let's continue from here.
Wow, you've done well, and by now you're aware that the Python list is pretty powerful. A list can hold any type and can hold different types at the same time. You can also change, add, and remove elements. This is wonderful, but one feature is missing, a feature that is super important for aspiring data scientists such as yourself. When analyzing data, you'll often want to carry out operations over entire collections of values, and you want to do this fast. With lists, this is a problem. Let's retake the heights of your family and yourself. Suppose you've also asked for everybody's weight. It's not very polite, but everything for science, right? You end up with two lists, height and weight. The first person is 1.73 meters tall and weighs 65.4 kilograms. If you now want to calculate the body mass index for each family member, you'd hope that this call can work, making the calculations element-wise. Unfortunately, Python throws an error because it has no idea how to do calculations on lists. You could solve this by going through each list element one after the other and calculating the BMI for each person separately, but this is terribly inefficient and exhausting to write. A way more elegant solution is to use NumPy, or numeric Python. It's a Python package that, among others, provides an alternative to the regular Python list, the NumPy array. The NumPy array is pretty similar to the list, but has additional features, such as the ability to perform calculations over entire arrays. It's really easy and super fast as well. The NumPy package is already installed on DataCamp servers, but if you want to work with it on your own system, go to the command line and execute pip3 install NumPy. Next, to actually use NumPy in your Python session, you can import the NumPy package like this. Let's start with creating a NumPy array. You do this with NumPy's array function. The input is a regular Python list. I'm using array twice here to create NumPy versions of the height and weight lists from before, NP height and NP weight. Let's try to calculate everybody's BMI with a single call again. This time it worked fine. The calculations were performed element-wise. The first person's BMI was calculated by dividing the first element in NP weight by the square of the first element in NP height. The second person's BMI was calculated with the second height and weight elements, and so on. Let's do a quick comparison here. First, we tried to do calculations with regular lists like this, but this gave us an error because Python doesn't know how to do calculations with lists like we want them to. Next, these regular lists were converted to NumPy arrays. The same operations now work without any problem. NumPy knows how to work with arrays as if they were single values, which is pretty awesome if you ask me. You should still pay attention though. First of all, NumPy can do all of this so easily because it assumes that your NumPy array can only contain values of a single type. It's either an array of floats, an array of booleans, or something else. If you do try to create an array with different types, like this for example, the resulting NumPy array will contain a single type, string in this case. The booleans and the floats were both converted to strings. Second, you should know that a NumPy array is simply a new kind of Python type, like the float, string, and list types from before. This means that it comes with its own methods, which can behave differently than you'd expect. Take this Python list and this NumPy array, for example. If you do Python list plus Python list, the list elements are pasted together, generating a list with 6 elements. If you do this with the NumPy arrays, on the other hand, Python will do an element-wise sum of the arrays. Just make sure to pay attention when you're juggling around with different Python types, because the outcomes can differ a lot. Apart from these subtleties, you can work with NumPy arrays pretty much the same as you can with regular Python lists. When you want to get elements from your array, for example, you can use square brackets. Suppose you want to get the BMI for the second person, so at index 1. This will do the trick. Specifically for NumPy, there's also another way to do list subsetting using an array of booleans. Say you want to get all BMI values in the BMI array that are over 23. A first step is using the greater than sign, like this. The result is a NumPy array containing booleans. True if the corresponding BMI is above 23, false if it's below. Next, you can use this Boolean array inside square brackets to do the subsetting. Only the elements in BMI that are above 23, so for which the corresponding Boolean value is true, is selected. There's only one BMI that's above 23, so we end up with a NumPy array with a single value, that specific BMI. Using the result of a comparison to make a selection of your data is a very common way to get surprising insights. Learn all about it and the other NumPy basics in the exercises.
Oh, interesting. So let's see how we can practice with NumPy. I think the most important stuff is to know that when you combine different data types in NumPy array, they behave differently. So you have to be pretty careful of how that works. Okay, so your first NumPy array. Before I start, let me launch my Anaconda Navigator. Okay. So I could open my own Python file via my Jupyter Notebook. So your first NumPy array. So you're now going to dive into the world of baseball. Along the way, you will get comfortable with the basics of NumPy. So a powerful package to do data science. So a list baseball has already been defined in Python scripts, representing the height of some baseball players in centimeters. Can you add some code to create a NumPy array from it? So we need to import NumPy package as np. Then we have a baseball list already. Create a NumPy array from baseball, np baseball. Print out type of np baseball. Okay. Okay, let me just open my own Jupyter Notebook from here. I'll launch my. So I've showed you how to download this from day one video. So you can quickly watch the part of day one video to know how to install this Anaconda Navigator and launch your Python environment so you can practice on your local computer. So there. Okay, so I'll just go ahead and locate the file. So my data sets here. This is my Jupyter Notebook file. So this was all we've coded from day 1 to day 4. So we are moving to NumPy here today. I'll just make it a markdown and call it introduction. So if you have this Jupyter Notebook, this Anaconda, if you access Anaconda, if you access Jupyter Notebook via Anaconda interface, all the packages must have been installed for you. You just have to call on them. You don't need to install them all over again. So introduction to NumPy. So let's continue from here. So it says import the NumPy package as np so that you can refer to NumPy with np. I'll just say import import NumPy as np So baseball. Use numpy.array to create a NumPy array from baseball. Name this array np underscore baseball. Let's create an array np underscore baseball. You want to create an array from this baseball list. So it's going to be np dot baseball np array rather open brackets baseball. So I want to print out type of NP baseball. It's going to be print type NP baseball. Let's go on the code and see. So the NP baseball is NumPy NP array. So you can see the class here. So let's copy the same code and practice same thing on our Jupyter notebook here. But one thing I will do first is to add a cell, insert a cell below. So I'm going to copy this here, but I'm going to import my package in an entire cell above here. So I come here and run this code. You can see it's run successfully without returning any error. That means the package has been installed. Then I'm going to run this code again. You can see so class np.array numpy.nd array. So it's working fine there. So let's submit the answer and see. Great. Please read this exercise. That will be later. Okay. Now, baseball players' height. So you're a huge baseball fan. So you decide to call the MLB Premier League Baseball and ask around for some more statistics on the height of the main players. So they pass along data on more than 1,000 players, which is stored in a regular Python list. Heights underscore in. So the height is expressed in inches. Can you make a NumPy array out of it and convert the unit to meters? Ooh, how do you convert the unit to meters? Let's see. Okay, so height in is already available and the NumPy package is located, so you can start straight away. So the heights, I need to import the data set into my local machine there. So create a NumPy array from height in, name this new array np underscore height. So create a NumPy array from height in. So I want to name this array np. So we've imported NumPy already. It's going to be np underscore height in inches equals to np dot array open brackets open bracket the height in inches. So we want to print out the height in inches. So to print it out, we're going to say print np height. Let's run the code first and see. So you can see the height here. You can see the height is a lot of data sets, but let me just import the data sets into my own Python package here. So to do that, I may just have to go. So for me to access the data set, I have the data on here. You can see it is a CSV file, which is the baseball file here, right here. So luckily for me, it is in the same folder as where my Jupyter notebook file. This is this Python file is located. So all I have to do is just import. To access that, I need to use pandas to access the data set there. I'm going to use, so they've not talked about pandas. We've not got to pandas, but I just know how to do that. Import pandas as PD. If I run the code, let's see. You can see some import. So with pandas, I can have access to this CSV file on my computer here. So to have access to this heights of the players here, which is already installed on the DataCamp platform. So let's go ahead and call on the file. So now I'm going to do is just say, so the file is a baseball abi. It is a soccer, let's see, it's a basketball MLB soccer Major League Baseball data. So I'm going to name the data MLB MLB right here. Dot read. So I'm going to use this code dot read underscore CSV. So open a bracket, CSV rather. Open a bracket and go ahead and point to the file. So what is the name of the file? It is MLB open bracket close bracket baseball. MLB open brackets close brackets baseball. I think it will be case sensitive baseball. So I have to put it in quotes for this to work. Oh, let me change my keyboard there. And this is actually going to work because I have the file in the same location as this my Python file. So let's run the code and see. Ooh, MLB is not. Okay. I think MLB is not defined. So I need to define MLB first. Oh, let's see. I'm making a silly mistake there. So I'm supposed to use the keyword. Okay. Mhm. Oh, okay. My mistake was this. MLB equals to. Okay, let me look at my mistake real quick here. So I'm trying to access the data. Okay. So it's going to be MLB equals to pandas. I need to use the pandas to call on the file. Ooh, mistake again. So no such file in the directory MLB baseball. It is in my directory though. So it's not saying the file MLB baseball. I need to check the spelling. I think what I need to do now, I need to rename the file pretty well. Probably it's not seeing the name, probably because of the brackets. MLB baseball. Oh, I've seen my mistake. .csv. I need to include .csv in my .csv. Now this should work fine. Aha. Oh, I'm not showing that. Sorry about that. So I didn't write the name of the file correctly. So I need to make sure I'm writing the name of the file correctly for you to see it. Okay. So now I have access to the file. So to see some of the data sets in the file, in this my file here, this baseball file here, I can use the keyword data. So I don't need to use the keyword. I need to call on the MLB or MLB and run it. You can see the file here. Now we're after the heights. The heights. So the data contain over 1,000 rows and 7 columns. You can see the 7 columns there. And if you compare this heights to the height record from here, you can see 747472 75573. The first data is 7472, you can see. Then 75573 to the end of the file, which is over 1,000 rows there. So what we could do is just see the first 5 rows. If you want to see the first 5 rows of the data, I think you can use data dot get, open and close the brackets. Oh. So sorry, I keep referring to data. I need to refer to MLB. So it will be MLB dot add. Now let's see. You can see. So I'm looking at the first 5 row of the data. So now let's move on according to. So we have access to our height record here also. So what I could just do right now, according to the instruction here, is to import NumPy as NP, create a NumPy array from height dot inches. So we need to create a NumPy array from, let me copy this. So that's what we're going to do, is to create a NumPy array from height here. So we call it height. So it will be height here. Let's see if it's going to work. Height is not defined. Ooh. Trying to define height here. Okay, height. Height is the other one here. So let me see how I can access the height here. Okay. Okay, let's see how we can access the height from the record here. So I'm thinking of using, so there's no way we can access the height record here. So that is by the way we do. So let me just delete this record of code. And let me continue from here initially. So it says convert NP heights into, so the NP heights from inches to, so we need to multiply, print NP heights, multiply NP height with 0.24 to convert all height measurements from inches to meters. Store the new value in a new array. So we need to multiply this NP height in inches with this value to convert it to meters. So we're going to say, so it's going to be NP heights in meters. So NP underscore height should not be meters equals to our NP height in inches multiply. So we're going to multiply by 0 0 0.0254 254. So now finally we need to print out our print the NP. So let's run the code. I can see it has multiplied by that. So my challenge is now recreating this in my Jupyter notebook. I just want to access this height record here. Okay. So we need to access only the column, this one column here from the data sets. What if I say MLB here dot the height in the table? Is that going to work? Let's see. So it's going to return the height only. So name, height, length. So you can see. So it return the height. So if I can create an array from this height here, that would be interesting. Just thinking how to do that though. I had no idea I could do this though. So I was trying to access only the first column here. So what if I want to now create an array out of the height? Let's see. So we want to create a NumPy array from the height. That should now be np.array. I can use np. Let's see if we could work np from the NumPy, our NumPy package here, np.array, open brackets. So I'm going to create an array out of that. Open bracket mlb.height. Okay, let's see. mlb dot height, height. Let's see if you're going to get something like that. Ooh, the object has no attribute height. Ooh, ooh, ooh. Well, if I say np.array, then height. Oh, probably because I was using a small letter here. Let's get back to a capital letter. Height is not defined. What do I say from the MLB data sets? MLB. Ah, it works. Yeah, so we could create an array from this column data of data here, you see. So I was able to connect to this file. So I'll drop a link to the file under the YouTube description so you can download this baseball data set, which is just 1,000 rows of record with 7 columns. So once you have access to it, you can call on the first 5 rows with this MLB, depending on what you use to define your MLB, depending on what you use to name your data from the beginning of the code here. Then once you have access to the data, once you must have imported a NumPy and pandas as PD, you're going to have access to the data as it's in a CSV file from your local machine. So make sure to save it easily on the same directory as the Python file, which is this Python file. This is my Jupyter Notebook file I'm using to access the file. So that's why you can use this simple code here. If you don't save it there, you have to use your system directly, the full directory from your system to access these data sets actually. So once you've done that, you could call on the data set and you're going to see a preview of the data set. You want to see the first 5 rows of the data set, use the mlb.head code. If you want to access a column out of the data set, you call on the data mlb dot the name of the column. Then I created an array from this column here, so we have access to it. Then we can finally go ahead and print out and multiply. Let me just copy from here. Go ahead and convert the array, which is in inches, to meters. Let's see. Oh, okay, my bad. So I'm using something else here. So mine is going to be mlb dot height here. Let me copy the correct name from my own data set here. Ctrl C. So mine is going to be mlb dot height. Let's see. This is going to be np meters. It's going to be mlb. So I'm going to print out this. Let's see again if it's going to work now. Aha, great. You can see I've converted it from the height from inches to meters. Yeah, you can see the 74, 74, 72, 72, 73. These are the first record. 74, 74, 72. You can see 1.11 here. Same thing, 1.11 here. So we were able to do the same thing from DataCamp and our Jupyter Notebook here. So just make sure you have access to the data sets here. Then you can start practicing immediately. Now let's continue. So we are on track. So submit. Oh, what's wrong? Use NPI times. Okay, only one's calculation. Okay, let's see. Oh, okay. I was using. Oh, I used two asterisk, which is going to mean exponential. I'm supposed to use one asterisk, which is actually for multiplication. So I'm so sorry about that. So this is the correct calculation. Correct. Nice. In the blink of an eye, NumPy perform multiple multiplications one on more than 1,000 height measurements. That's true. The record here is over 1,000 rows of data. You can see. So we have calculated measurements in Python just like that. So let's move ahead to the next one. So NumPy side effect. So NumPy is great for doing vector arithmetic. So if you compare its functionality with regular Python lists, however, some things have changed. First of all, NumPy arrays cannot contain elements with different types. So NumPy array cannot contain elements with different types. That means you can't have this data set here. You can't have heights in numbers and position in text for the calculation. It's not going to work. So you're probably going to get an error like that. Okay. First of all, NumPy arrays cannot contain elements with different types. Second, the typical arithmetic operators such as plus or minus, multiplication and division have a different meaning for regular Python lists and NumPy array. So for a list and a NumPy array, this basic arithmetic calculation, they have different meanings when it comes to NumPy. So some lines of code have been provided for you. Try this out and select the one that would match this. So npra2 212 plus npra 3 4 false. The NumPy package is already imported as np. If I try to copy this array, let's see. Let's see what we are going to get. Let's see. We could actually run it here and see. And let me hit enter here. So it's sum of the array 4, 5, 2. So 3 plus 1, 4. 2 plus 4 plus 2. It's kind of funny though. Instruction. Possible answers. So okay, let's see. Let me use the same code on my Jupyter notebook and see what is going to happen. So it is summing it up. So what calculation is it doing here? 2 times 3, probably. So 2 is 1. Okay, the 2 version here, 2 means 1, or false means 0. So it's saying 1 plus 3 will give me 4. 4 plus 1 would give me 5. Then 2 here is 2, and false is 0. So 2 plus 0, 2 plus 0 will give me 2. So understood there. So that was the result of that code. Okay, now let's see possible answers here. What are you showing? So 2 is no 1, 1. So this is the possible answers there. Okay, hold up. This 2, 1 plus 3, which is 4. 1 plus 3, then this has to be 0 here. Mm, hold up. 4. Okay, this no. The answer is 4, 5, 2. So it's not even telling me the answer straight up. Oh, what was the challenge? NumPy, this is not the answer. Hold up. 4, 3, 0, 0, 2, 2. Okay, 4, 4, 3. Okay, it was rearranged. 4, 3, 0. Okay. 4, 3, 0. Then this will be 1, 0, 2, 2. Why? Why is it 0, 2, 2? This should be 2 here. This will be 2 definitely here. Let me see what it says here. Great job. 2 is converted to 1. 4 is converted to 0. Exactly. 2 is converted to 1, but it wasn't converted here. NPRA, that should be 430. 430 here. 211. 211. Something is missing. It's supposed to be 2, 2. Why is it 2? It's supposed to be 211. But that's by the way, though. We kind of understood what we are doing here. So from the simple calculation. So subsetting NumPy arrays. So subsetting using the square bracket notation on lists or arrays. On lists or arrays. So work exactly the same way with both lists and arrays. So this exercise already has two lists, height in inches and weight in LB in the background for you. So this contains the height and weight of MLB players as regular list. It also has two NumPy array, list NP weight LB and NP height in inches prepared for you. So print out the weights at index 50. So at index 50, okay, let me have access to this list first for my data set here. So I could say, whether my code I use? NP LLB. Okay, I converted it to height. I could just come here and say MLB, MLB height, and MLB dot weight, which is the weight here. Weight, okay. If I run the code, so I have the weights. Where's the weights? It is showing me I want the two data sets. Let me not make an array out of them though. So NP MLB. Let me make an array out of the record there. So when I make an array out of the record, it's going to be weights. Let's see. It should make sense better. It's only returning one array. Why? Why one array though? Can't I have both of them in one row? Let me see. So it's printing these weights, these heights. Why is my height the same thing as the weight? That's supposed to be the same thing though. Let me see what's the mistake here. Is there an error here? MLB.weights WEI. Hmm. So it's returning the weights 180. What about here? So the weight is standing for 180. While I want the heights. The height was returned here. Heights. I'm going to the heights. Better. Then we have the weights here. Or better. So we have our record. So if we created an array as it was done here. So it's now saying, okay, subsetting using the square bracket notation on lists or arrays works exactly the same way with both lists and arrays. So this exercise already has two lists, heights in inches and weights in LB, loaded in the background for you. So this contains the height and weight of the MLB players as regular lists. It also has two NumPy array lists, NP weights and NP heights. Prepare for you. So subset NP weight LB by printing out the element at index 50. I want to print out the element at its index 50, rather. So we're going to call it hmm, let's see. We're going to mention the array NP weights. So we want to print out the array. We just want to use a subset with a square brackets. Where's my square bracket? At index 50. Let's see. Index of 50. MLB. Weight, right? So it's going to be MLB weights here. Other, I'm going to use the correct array name for this. Hold up, hold up, hold up. My array is MLB weights. Let's see. So guys, index 50 is 200. The value is 200. So you can see that. What about the next one? The next one says print out subarray of NP height inches. So it's going to be NP height in inches at index, or now it's not mentioning the index, at index 100 up to including index 110. So I have to mention index 100, 100, right? 100 up to, let's see, up to 110, including up to and including index 110. Let me see how this trick is going to work. This is going to start at index 110. Let me see first. Let me copy this first here. Now we want to work with the height. I want to test it in my code here first. It's going to be MLB dot height here. Height in inches. Let's see at index. You can see all the way index 100 up to index 110, including index 110. Just to make sure and do index 111. Let's see. Wow, 100, 101, 102, 103, 104, 105, 6, 7, 8, 9, 10. So that should be index 111 all the way to index 111 here for this to work. Let's run the code. You see, so this is our array for this index 50. Where's index 50? It's not showing index 50 here. It's also showing the value of index 50, which is 200, which is the record in this all data sets at row 200. That was it just mean there, row 200 of that data set. So that's all it means there. So let's see if you are correct. So have you used print? Okay, I didn't print it out. Or I didn't print this out rather. Okay, print out. Oh, silly mistake there. So print. So I could just print it out. So I need to print out this one also. So the instruction was print. Print. Let's run the code. So this is basically, see, the index 50 is 200, while index of this is that. That's great. But in my Jupyter notebook here, do I need to print it out? It just show this immediately. What if I wrap it in print also? Let's see. It's going to return same record though. Same record. Jupyter notebook is quite just fast and easy to use. If I print it out, let's see what it's going to return. It's returning the same value. So, ooh, just a second there, real quick. Just a quick one there. Okay. Yep. So I'm back. So I think we've discovered and answered all the necessary questions for this index. So let's move on. Just a quick break there. So next time, try to learn something new. 2D NumPy array. Okay, let's go to 2D NumPy array. What is that all about? Ooh, we still have a lot of challenge to go through here. So let's see how we can do this. Let's wait for this to come up.
Well done, you legend. Let's now recreate the NumPy arrays from the previous video. If you ask for the type of these arrays, Python tells you that they are numpy.ndArray. NumPy dot tells you that it's a type that was ndArray stands for n-dimensional array. The arrays np height and np weight are one-dimensional arrays, but it's perfectly possible to create two-dimensional, three-dimensional, heck, even seven-dimensional. Let's stick to two in this video though. You can create a 2D NumPy array from a regular Python list of lists. Let's try to create one NumPy array for all family like this. If you print out np 2D now, you'll see that it is a regular data structure. Each sublist in the list corresponds to a row in the two-dimensional NumPy array. From np2d.shape, you can see that we indeed have 2 rows and 5 columns. Shape is a so-called attribute of the np2d array that can give you more information about what the data structure looks like. Note that the syntax for accessing an attribute looks a bit like calling a method, but they are not the same. Remember that methods have round brackets after them, and you can see here that attributes do not. Also, for 2D arrays, the NumPy rule applies. An array can only contain a single type. If you change one float to be a string, all the array elements will be coerced to strings to end up with a homogeneous array. You can think of the 2D NumPy arrays as an improved list of lists. You can perform calculations on the arrays, as I showed before, and you can do more advanced ways of subsetting. Suppose you want the first row and then the third element in that row. To select the row, you need the index 0 in square brackets. Don't forget about zero indexing. To then select the third element, you can extend the same call with another pair of brackets, this time with the index 2, like this. Basically, you're selecting the row, and then from that row, do another selection. There's also an alternative way of subsetting, using single square brackets and a comma. This call returns the exact same value as before. The value before the comma specifies the row. The value after the comma specifies the column. The intersection of the rows and columns you specified are returned. Once you get used to it, this syntax is more intuitive and opens up more possibilities. Suppose you want to select the height and weight of the second and third family member. You want both rows, so you put in a colon before the comma. You only want the second and third column, so you put in the indices 1, comma. Remember that the third index.
So you want the heights. So a colon means so from body row version of 1 to 3, note it's 1, 2. Going to return the first two rows there, the first two column rather. Okay, understood.
Index is not included here. The intersection gives us a 2D array with 2 rows and 2 columns. Similarly, you can select the weight of all family members like this. You only want the second row, so put 1 before the comma. You want all columns, so you use a colon.
You want the second row. So you want the second, then all records before the comma. Okay.
After the comma. The intersection gives us the entire second row. Finally, 2D NumPy arrays enable you to do element-wise calculations, the same way you did with 1D NumPy arrays. That's something you can experiment with in the exercises, along with creating and subsetting 2D NumPy arrays. Get coding, have fun, and see you back here soon. While I wait, I may even code a bit myself.
Okay, let's give this a shot. Do the NumPy array could be tricky, but let's see how we can do that. Okay. So you're forced to the NumPy array. So before working on the actual MLB data, let's try to create a 2D NumPy array from a small list of lists. So in this exercise, baseball is a list of lists. So baseball is a list in a list. So this is a list. This is a list in another list, which is the first two square brackets here. So use our NP array to create 2D NumPy array from baseball. Name it NP baseball. Create 2D NumPy array from baseball. So to create a 2D NumPy array from baseball and call it NP baseball. Let's call it NP underscore baseball. This is going to be with this also in my Jupyter notebook here. Let's see what baseball equals to. So these are baseball 2D array. So it says create a 2D NumPy array. How do you do that? I'm going to call it NP baseball equals to NP baseball. NP dots baseball. Let's see. Let me create the same thing here. Copy the codes. Let's test it out here. Ooh, NumPy has no attributes. Hold up, hold up. Okay, mine is going to be MLB. Hold up. It's my baseball from here. Okay. Sorry. Let's see. Let me run the code again. Okay. But I should be able to print it. Let me print it out. Let me just call NP baseball there. Underscore baseball. So look at the array here. 180. I want it to be a 2D array rather than just a single. Let's see. It's going to be okay. I'm missing something. I'm missing a step here. So it's going to be NP array. Open brackets. I'm going to open brackets. Okay, hold up. NP array. So I'm going to refer to the baseball here. Then baseball. Okay, now let me not do this better again. NP array base. And let's see that better. So I figured it out. So I wasn't doing it very well before. And so now we have our 2D array back here. So you can see that here. It's not a 2D array. So we're getting it on track. So print out the type of NP baseball. The type is going to be the type keyword. Type NP baseball. So print out shape of NP baseball. So let's print out the shape. It's going to be the shape is going to be NP baseball. NP baseball dot shape. Let me now copy this. I want to print it out, so we need to print it out here. Let me copy it first. In Jupyter Notebook, we don't need to print it out. It's going to print out print. In this case, then we're going to print also print this. In this case, let's run the code and see. Now let's see it in my data notebook. So mine is going to be the MP baseball. MP baseball is the MP array. MP baseball. I say it is the shape is 4. Nope. The type it's not showing me the type. The shape is going to be 4 rows. Yeah, 4 rows, 2 columns. That is the shape. But I need the type also. Okay, let me copy this out. Let me just cut this. The type is NumPy. It's the NumPy array. And the shape it is the 4 rows, record, and 2 column. Let's see it in answer. You can see my print is not showing here. Let me submit the code first. Oh, great. So great. You are ready to convert the actual MLB data to a 2D NumPy array. So now we need to convert this actual MLB data to a 2D NumPy array. This is our MLB data here. We can convert some of the columns there to a 2D array like this. It's going to tell us the number of rows and number of columns that we have there. Interesting. So it says baseball data in 2D form. So you realize that it makes more sense to structure all this information in a 2D NumPy array. So you have a Python list of lists. In this list of lists, each sublist represents the height and weight of a single baseball player. The name of the list is baseball. So we have our data here also, the height and weight of a single baseball player. Let's say how we can convert this into a 2D array. So it will be something similar to what we have here. So this is for a baseball player, the height and weight of the baseball player. Interesting. Okay, let's see how we can do that on data sets. So you have a Python list of lists. So in this list of lists, each sublist represents the height and weight of a single baseball player. So the name of this list is baseball, and it has been loaded for you already, although you can't see it. Maybe I can see it. I'm too smart for that. Store the data as a 2D array to unlock NumPy's extra functionality. So import NumPy as NP. So use np.array to create a 2D array from the baseball. Name it np baseball. Okay, np.array. But I'm thinking of how do I do the same thing in my Jupyter notebook, which I can point to this columns here. I'll use it in a 2D array. But I'll figure it out. Let me give this a shot first on DataCamp. So this is going to be np dot array open brackets, or we're going to call it baseball. So print out the shape of the np baseball. It's going to be np baseball dot shape. Let's run the code. So it's telling us it has 1,000 plus rows and 2 columns. Now let's do the same thing. Let's recreate the same thing in Jupyter Notebook. Okay. Now I'm going to call this. So my baseball. This is my baseball. I'm going to call it MLB. Let's call it MLB. So I'm going to refer back to my data here, which is the MLB column here. Okay, now let me call out the MLB column. I was trying to call it out the other time, same way like this. So I'm trying to call it out like this here. MLB dot heights. Let's see if you can do it here also. It's only showing me the width, length. These are the rows, these are the record. What if I want it to be? Let me now print. Let me see if I can print it out. Prints. Okay, let's see if I print it out. Uh, you can see I have the heights first, then the weights second there. So I could print it out. So it's going to show me individually. So how do I convert it to an array like this also to a 2D array? Mm, hmm. I'm thinking. Print out the shape. Let me think. How do I combine this together? Let's say we did it here. Mm, create a 2D array. It's going to be called np. Mm, let's say MLB baseball equals to np.array np dot array open brackets. What do you call it? MLB. Let's see what it's going to give me. Okay, that's created an array, but it's not showing me. So if I say MLB underscore baseball now, baseball, let's see what it's going to return. So it is only the array. You can see it has converted it to an array. Oh, interesting. But it's not only converting the heights for me, it's converting the whole columns for me. But that is still closer to what I want to do. But I don't just want to only convert only the heights and row. I don't think there's a way I can easily access that only from there. Hmm. Consider because this list here contains the height and weight, but I could also get the shape. So I cannot say, okay, MLB baseball dot shape, MLB underscore baseball dot shape. So the best offer I could get is same record as 1015 and two. So it's going to show me two columns there, but this is going to show me 7 columns in my slide there. You can see 7 columns. Because there's no way it's not easy for me to only access the two columns here. And I can't find a way. But probably there's a way, but I don't find it. I can combine. I can just select the two columns and create a data set. I need to create the entire data column. I think that's possible though. First, if I create a variable and assign the value what if I create a variable and assign the values height and weight to it? Let me see. So I create a variable called okay baseball. Let me create a variable called baseball. Let me see baseball height and weight. Baseball height and weight is going to be equals to MLB dot Python code is kind of tricky though. MLB dot height and dot weight. Is that possible? Dot height. Let's see. Dot weight. Is that possible? Is that possible? I'm going to get an error. Exactly, I'm going to get an error. But let me just stick to it. So my data is connected to 7 columns rather. So it's still closer than that. But let's continue from here then. Oh, it's saying print, so I didn't use print here. Print, okay, let me print. Even though I could see the shape here, it's still asking for print. I'm getting same record though. So sleek, time to show off some killer features of multiple dimension NumPy arrays. Okay, let's continue. Setting 2D NumPy arrays. So if your 2D NumPy array has a regular structure, each row and column has a fixed number of values. So complicated ways of subsetting become very easy. Have a look at the code below, where the elements A and C are extracted from a list of lists. Import NumPy as NP. NPS is np.arrayx. NPX is, so the indexes before the comma refers to the rows. Okay, this is the rows and this is the column. While those after the comma refers to the column. This symbol is for slicing. In this example, it tells Python to include all rows. Okay, so if you want to include all rows, you have to use this symbol. So this one now says print out the fifth row of NP baseball. So we have our NP baseball already. Print out the fifth row, 50th row, the 50th row. Then we want to have the whole column. So I'm going to say include all column. So I can say NP baseball here. NP baseball here. Square brackets. The 50th row. So my first 50th row, comma, include all column. Let me see if I can do the same thing in my notebook. Hold up a second there. Let me see if I can print out the 50th row here. So mine is going to be MLB baseball rather than MP baseball. Let's see. Interesting. So the 50th row is going to return all the record in that row. You can see. So the 50th row is Charlie, is a central wing or starting pitcher. This is height, this is the weight, and this is another record here. What's the other record here? The age. Okay. How about this position? So the position is coming here. But let's see if I can recreate the same thing in DataCamp here. That means we got the, let's select the entire second column of MP baseball. The entire second column. Second column. So we know that the first column is going to have the index of 0. Okay, let's say NP baseball. The second column. Select the entire second column. Entire second column. So entire second column. I'm thinking entire second column. So this is for the row. So the first row is going to be 0 though. So if it's going to be entire second column, so the entire second column is going to be 1. Let's see. Let's see. So since I want the entire second column, I can just use same. Since I want the entire second column, so the row is going to skip. Let me see this in action first. Let's test it out a little bit. So I'm going to change this to MLB baseball in my end there. Let's see. Ooh. So this is the second. Let me go and confirm from here. I see the second. This is my own second column, my entire second column. That means I'm correct. It's just printing out team BA, SSC. Absolutely correct. You can see BA. It is keeping the. So if I want it, what's the instruction there? It says the dash is when it's for slicing. This example, it tells Python to include all rows. So I want to include all rows in my second column. So this is working. So all rows from that second column. Okay, I understood now. So this is what it is for. So you print out height of the 124th player. Height of the 124th player. NP basketball. Height of the 124th player. Now let's come down. That's tricky. So we want the height of the 124th player. That will be 124th row. Since I don't want the whole column, I can say 0, then 125. Let's see. So it's going to exclude 125 there. Let's see that in action. Let me test it out here. So same thing is going to be MLB baseball for the array. Okay. Now let's see this in action. Ooh. Index 125. Oh. It said index 125 is out of 1 for axis 1 with size 7. 125. If I use 1, let me see what if I use 1. Same thing. Okay. But my data set here is over 1,000 rows now. Why is not returning this error here? Okay, let's test it out. Print. Okay, so it's saying print. Okay, I have to print here. Let me print out on DataCamp here. Print. Now let's see. Ooh, you can see I'm in there's 125 is out of bound for axis 1. So let me now go to 124. Let's go for 124. Wow. So print out the height of 124th. Okay, height of 124th player. What does that mean? Select the height of the first column of the 124th base B player. Okay. This one says select the height. Okay, so it says make a new variable np with lb. I didn't follow the instruction very well. So np with lb. Yeah, I should make a new variable for weights. So I didn't follow the instruction pretty well, yeah. This is supposed to be np weights lb. I didn't read the instruction. A new variable is going to be equals to this. Okay. So I've done that. NB with LB containing the entire second column of NB baseball. So print out the heights of the 124th player. Oh, let me explain the error. Let's see. I was getting same error here. That means I'm doing something wrong. Print, it says, oh. It's supposed to be the opposites. Oh. So what you should, the problem here is that you are trying to access an index that doesn't exist of NP baseball. Oh, okay, let me now correct it from here first and see. Okay, this is supposed to be 0. Supposed to be 0. Let's say this one is 1 and 0. Cool. But it says the height, okay, 123 and 0. Casting go back. Let me see the mistake that was happening. They print out the heights. Print out height of the 124th players. Let me look at the instruction again. Says, what is this here? The point is that you are trying to access an index that doesn't exist. So I'm trying to access the height of the 124th player. The height. So this is the column. Which one comes first? In an index. Okay. When it comes to an index, 2D arrays are arranged or horizontally, not vertically. So I was looking at it vertically rather than horizontally. I was also looking at it this way. I was looking at it like long. So I'm supposed to be looking at it like it is wide, not long. You get it now? It's actually wide and not long. But notwithstanding, this 1,000 rows and 7 columns does the trick though. Probably because it is different from the way it is. Okay, that's by the way though. Let me run this code now and see. Ooh, so it's supposed to be 123. Oh, what is the challenge? Hold up. Oh, it's supposed to be the opposites. Okay, 123, 123, 124 first, and 0. Okay, let's see. Aha. You can see now it's not making sense, but there's something I'm missing. It says print out. Okay, let me explain this error again. So to fix, you need to access the height of the 124 player correctly using the height index for the rows and columns. So it says, if I go back to the previous exercises, hold on, let me copy this first. Why is copy here? I'll just copy it because this first thing is the row, this is the column. So I'm saying move 0 column. Oh, the challenge is that for this array, we only have two columns there. 2 columns, exactly. That was the mistake I was in. We only have 2 columns in this instance there. But notwithstanding, I have more columns in this record. They have columns. There's no column like 120. Oh. So the highest column here is 7 column, not 124 columns. So this is the first one here is the rows. The second index here is for columns. So I was trying to access the 124th column, which doesn't exist. Oh, my bad. So that was my mistake there. I need to print it out. Well, have you used print 49 to do the appropriate printout? So for this one, it says print out the 50th row of the MB baseball. 50th row. No, 50th row. It's going to include, okay, this is including 59. Hold up. 49. 78. 50th row, 70 and 195. Oh, this one I'm supposed to be using 123 here. This one to print out the height of 124 player. I'm supposed to be using 123. Is it going to include the 123 row, the 123rd row rather? I need to go back to this challenges to the array and understand it better. Probably I'm going to watch it. Okay, let's see. Print out the 50th row. Okay, 50th row. I have to use the 49th row to access the 50th row. Reason being, so I need to figure out this one more time on 2D arrays one more time to understand it better. Okay. Oh, that's quite a lot though, but we spent over an hour here, so let's continue to move on while I go back and try this all over again. It says 2D NumPy arrays can perform calculation element by element like NumPy arrays. So NP baseball is coded for you. It's again a 2D NumPy array with 3 columns. So this system, we have 3 columns there. You need to pay attention to the number of columns this time around. So the first index is for the rows. The second index is for the column. So representing height in inches, weight in pounds, and ages in year. So baseball is available as a regular list of lists, and updated is available as 2D NumPy array. Okay, print out addition of NP baseball and updated. Let's print out the addition of NP baseball and updated. So it will be the same thing. It's going to be prints. So it's going to be NP baseball plus updated. Where is updated? It's not seeing the updated in the memory. Updated. Create NumPy array conversion. So you managed to get hold of changes in height, weight, and ages of all big players. It is available in 2D NumPy array updated and NP baseball and updated. Is available in 2D NumPy array updated. Add NP baseball and updated to print out the results. Okay, you want to convert the units of height and weight to metric, meters, and kilograms, respectively. As a first step, create a NumPy array with 3 values. Create a NumPy array with 3 values, 0 point this, 0 point this, and 1. Name this array conversion. Okay, let's name an array. It's going to be NP array. We need to we're going to call it conversion. Conversion to be equals to NP dot array, and it's going to three values, 0 points. So we're going to be open brackets. So this column, so how do we create an array there using this format here? So I'm going to create it like this, just rows. So it's going to be 0 points. Let me see that one more time. I want to create an array for conversion. It's going to be 0.2, 0.0254, 0.0254. I need to put comma there. I don't think I need to put comma there. Let's see. Let's see though. This is going to be 0 points, 0 points 4545353592, and finally the last one. Last one is going to be 1 and 1. Okay. But I don't know if I'm going to use a comma there. Let's see. Let's put a comma here. Okay, let's see. So print out the product of NP baseball and conversion. So multiply NP baseball with conversion, print out the results. Okay, it's going to be NP prints NP baseball plus conversion. Let's see. Results here. Print out product of NP baseball and conversion. This is multiplying this by, you can see the results here. Now let's see if we got it correctly. Ooh. So they print out the product. So the product, not the application. I'll summing it up. That's will be the product. So the product is easier now. Okay. So our conversion that we created, which is an NP array, is correct. We need to include the comma there. So great job. Notice how with very little code, you can change all values in your NumPy. Let me try it out with this. I'm going to try this out with this other code here called this my NP baseball here. This baseball record here. So if I was to call on NP underscore baseball, let me call on NP baseball here. NP underscore baseball is going to be equals to this array. Interesting. So I'm going to go back. I'm going to create another version here. Let me create this, use this code here. Control C. I'm going to create another array in the code. So create a NumPy array conversion. This is my conversion NP array. This. So I'm going to print out. Let me delete this first. Control X. I'm going to create this array, just a simple array. Let's see. So it has been created. I can call on its conversion. Conversion is going to return this record for me, this simple array. Can you see? So now I'm just going to say NP baseball here. Ooh, nice conversion. Ooh, why? Open could not be broadcast together with shape. Why? So I'm still getting same error. Prints. So I don't even need to print it though. Let me see if I just say NP baseball. Oh, I'm still getting same error. Why am I getting this error? Conversion. Then this error. Why? Print out the product of NP baseball and conversion. This is my NP baseball here that we created from this array here. Baseball array. NP baseball equals to NP array under full bracket baseball. But you should be able to multiply it for me though. Oh, I'm not getting the multiplication. Why? Why? Let me see. Print out addition of NP baseball and updated. But the updated was created initially. Yeah. Okay. Let's continue. I couldn't get that. Good. Now, notice how with very little code you can change all values in your NumPy data structure in a specific way. This will be very useful in future as a data scientist. I couldn't get this challenge there, so I'll just skip it for now. I need to figure out why I'm getting this error here though. Let me delete this and try it again. NP baseball times conversion. Is that how it works? Okay, the shape. Oh, okay. The shape is different. Oh, this shape is 4. This is 4 by 2. 4 rows, 2 columns. Why this shape is 3 rows, 0. Oh, I've seen my mistake now. This shape is 3 rows, 0 column. But not notwithstanding, when I did it here, it was. So I need to come out. Okay, I'll come back to this and back to same number of rows. Okay. But how did we this conversion? Okay, we do it earlier. Let me see. What if I do it like this? Same way we did it earlier. Let me now see the results of my conversion. It's still saying the same error. Okay, so it's still saying the same error. That probably definitely what was used there. They were the same rows of column and shape. Okay. I think I understood this better now. I'm going to figure out. Let me now say, okay, say 0. Let me first 0 is there, then comma 0. Now let's see. I forgot the comma where I get the comma. Let me see here. Okay, there's supposed to be a comma here. Oh. Hold up. I'm supposed to close this shape here. Comma. This shape here. This shape here. Then a comma. Finally, that is the last one there. Let's see. Doesn't match. Okay. There's something missing here. I need one more parenthesis there. Okay. Ooh. There's supposed to be a comma here. Okay, there's supposed to be a comma here. Okay. There's supposed to be a comma there. There's supposed to be a comma here. What am I missing? So I'm missing something within my code here. But it's kind of interesting to run into errors sometimes. Let's see. Okay. Oh, I'm still getting an error. What is the error all about? Closing parentheses does not match opening parentheses. Okay. Let me just get rid of this first. Let's go back to our initial array. Okay, about this result, it was the 4. We are still getting this error here. Probably I'll come back to this error or later so we can finalize the last part of this basic 6.
A typical first step in analysing your data is getting to know your data in the first place. For the NumPy arrays from before, this is pretty easy because there isn't a lot of data. However, as a data scientist, you'll be crunching thousands, if not millions or billions of numbers. Imagine you conduct a citywide survey where you ask 5,000 adults about their height and weight. You end up with something like this, a 2D array which I named NP City that has 5,000 rows corresponding to the 5,000 people and 2 columns corresponding to the height and the weight. Simply staring at these numbers like a zombie won't give you any insights. And zombies can't even interpret numbers correctly anyway. What you can do though is generate summary statistics about your data. Aside from data structure for number crunching, it happens that NumPy is also good at doing these kinds of things. For starters, you can try to find out the average height of these 5,000 people with NumPy's mean function. Because it's a function from the NumPy package, don't forget to start with np dot. Of course, I first had to do a subsetting operation to get the height column from the 2D array. It appears that, on average, people are 1.75 meters tall. What about the median height? This is the height of the middle person if you sort all people from small to tall. Instead of writing complicated Python code to figure this out, you can simply use NumPy's median function. You can do similar things for the weight column in often, these summary statistics will provide you with a sanity check of your data. If you end up with an average weight of 2,000 kilograms, your measurements are probably incorrect. Apart from mean and median, There are also other functions like corecoef to check if, for example, height and weight are correlated, and std for standard deviation. NumPy also features more basic functions such as sum and sort, which also exist in the basic Python distribution. However, the big difference here is speed. Because NumPy enforces a single data type in an array, it can drastically speed up the calculations. Just a side note here. If you're wondering how we came up with the data in this video, we simulated it with NumPy functions. We sampled two random distributions 5,000 times to create the height and weight arrays, and then used column stack to paste them together as two columns. Another awesome thing that NumPy can do, and that you'll learn to do in the next course. Another great tool to get some sense of your data is to visualize it, but that's something for the next course also. First, head over to the exercises to learn how to explore your NumPy arrays. And so many congrats on making it this far. You've come such a long way.
So literally speaking, the dataset connected to within my Jupyter notebook was generated with NumPy. That's interesting though. So I'm still coming back to this though. Let me just, I want to get rid of this. I'm just going to paste this, but I won't run it. Let me add the code below. I'm not going to run this code. Just use something to differentiate that I need to come back to this code. Understand what is happening here. So let's finalize our challenge. 2 hours of practice. And there's a lot to practice with though. You can't really do all that in an hour. That's quite interesting to see. So let's say average versus median. So you may now know how to use NumPy functions to get a better feeling of your data. Both data is available as a 2D NumPy array with 3 columns. So we have a 2D NumPy array with 3 columns: height, weights, and age, and in over 1,000 rows. So the name of this NumPy array is NP baseball. So after restructuring the data, however, you notice that some height values are abnormally high. So follow the instruction and discover which summary statistics is best suited if you are dealing with the so-called outliers NP baseball. Okay, so create a NumPy array NP height inches that is equal to the first column of NP baseball. We want to extract the first column from our NP baseball. Oh, okay. We don't have to say, okay, create a NumPy height in form from the NP baseball. Say create, so it's going to be NumPy NP underscore height. I was looking for how to do this earlier before. Height in inches. I'm going to create a variable. So it's going to be NP array, open brackets, the first column of NP baseball. Let me see, how do we do that? Okay, hold up. Hold up. Go to the first column of NP baseball. So I could just use the array index to return that. Okay, let's see. The index, so I want to return the first column from the baseball team. So it's going to be 0, 0, then return audio rows in the day. Let's see. That should do the trick though. So print out the mean of NP heights. It's going to be print. So I want to print out the mean of NP heights. It's going to be NP dot mean. Okay. So I could do the same thing. I want to do this trick also for my MLB baseball team. Hold up a minute there. My gadget is low. I'll just plug it to the power source. Okay. So if I can use the array function to extract. So this is going to be np min. Print out the mean of the np its. Okay. So I'm going to np min, open brackets, open brackets, also open brackets. So I'm going to point to np-its. So print out the median of np-its. It's going to be the same. I'm just going to copy this real quick. So this is going to be median instead of mean. Median, let's see. Ooh. So built-in function or method object is not subscriptable. Or what's the challenge there? Let's take an explanation from the error. So I was supposed to be using np-its and point to the array, but I've already discovered the array here already. So I need to still point to it. Okay, np-its equals to. Okay, I'm supposed to use a function to create an np-its from the np baseball. So can't I do that? Okay, hold up. Okay. Brackets. Hold up. Hold up a minute. Create a height from the np baseball. Say the first column of np baseball. But we know that the baseball data contains 3 columns. So I'm trying to select the third and only column there. Okay, let's see. The solution given was I should use np baseball. Okay. np equals to np underscore baseball. Oh, okay. Okay, my mistake was okay. np baseball. Okay, let's see. All I have to do is just convert this to baseball. Okay, baseball. Okay, let's see. Let's run the code again. Oh, so it's not saying the attribute baseball. It's supposed to be okay. It's also np slash baseball. I think refer to the name pretty well. Oh, come on. It says create a NumPy height that is equal to the first column of np underscore baseball. Okay, let's see the error again. On the final end of the challenge, so we're now facing challenges now. Oh, ooh, come on, this is not a good time. Okay, now we figure it out. So interesting. Okay, we figured it out. Let's submit the answer and see. Oh, you can use the NP baseball to select the first column. This is what we need to use. Select the first column. Okay, rather than this. Once you select the first column, return all the rows, but return the first column. Okay, this is the rows, this is the column. Oh, that was the answer there. Interesting. So the final one is the challenge here. Explore baseball data. So I'm going to lose my source of power. So that will be the end for the live stream for today. I'm going to do this off camera and show you the results tomorrow. Alright, so thanks for staying to the end of the live stream. I have to end the live stream because my power source is about to run out and it's just going to end abruptly. So I don't want that. So do what to support the channel by giving the video a thumbs up, hit that subscribe button, and put on the notification bell so you'll be the first to know whenever I go live or drop a new content on the channel. So I'll be concluding this first thing, I'll be concluding this part